We actually have a TED Talk sort of presentation that's going to be given to us, and it's from Will Bruey. And Will Bruey, he's the CEO of Varda Space Industries. Will started his career at SpaceX, where he was a hardware engineer working on the Falcon rocket and Dragon spacecraft before flying 8 flights to the ISS, that's International Space Station as far as I know, from mission control as the lead of the Dragon spacecraft. He subsequently spent time at Bank of America Merrill Lynch as a director of global equities technology before founding Varda Space Industries in November of 2020, where he serves as CEO. Will holds a BS in Applied Physics from Cornell and a Master of Systems Engineering from Cornell. In his free time, he maintains and flies his Cozy Mark IV experimental aircraft. Will?
Are we good to go? All right. Hello, everyone. My name is Will Bruey. I'm the CEO of Varda Space Industries. And Varda is the first in-orbit manufacturing and Earth reentry logistics company. And our mission is to build an in-space economy to better life back on Earth and eventually beyond. And we're working on it not 10 years from now, but today, because something has changed. Over the past 70 years, we've spent decades of time and billions of dollars learning how to get to and from space, how commercial products can be developed in space, everything from fiber optics to pharmaceuticals to unique alloys, products with tremendous value back here on Earth. But all that value has been relatively untapped over the decades. And there's only one reason for that, and it's cost. But that's all changing now, thanks to the invention of reusable rockets at SpaceX and all the other launch providers coming online. I see Relativity here. And they are dramatically lowering the cost by an order of magnitude to get to space. And so now there's only 2 things left to do. First, create the manufacturing apparatus in orbit to manufacture products in space. And second is to be able to bring them back to Earth at a rapid and cost-effective cadence. And that's never been done before until now, until Varda. So my goal for this chat with you guys is to have it click of how close this reality really is. So manufacturing in space, it's closer to El Segundo than you think. So let's start with space itself. Space is way closer than most people think. The technical definition for space is only about 100 kilometers up. So that's about the distance from here to Riverside. Not exactly the epic adventure of the movies. And most satellites are about 3 to 4 times higher than that. Ours are actually lower, but about twice as high. And so it's about the distance from here to Palm Springs, except straight up. So first, space is actually closer than most people think. Okay, so why on Earth would we manufacture in space? Well, space is a unique environment. There's no gravity. And a unique environment with no gravity means that we can create unique products. And those unique products can't be made anywhere else on Earth. In fact, they're so unique, all of engineering is built on the 4 fundamental forces of physics: gravity, the strong nuclear force, the weak nuclear force, and electromagnetism. And we have the ability to change 25% of those physical laws for the manufacturing engineer. And so since all of engineering is built on these 4 laws, there is a whole hell of a lot of innovation to be done when we change 25% of the foundation of the reality in which we exist. So I'll give an example real quick to visualize one aspect, chemistry. So let's say balsamic vinaigrette dressing in your refrigerator. Normally, if you let it sit there, it separates. And that's because the heavier elements drop to the bottom, and the lighter elements float to the top. And now let's say I wanted to perform a chemical reaction, but I needed that mixture to stay homogeneous. I needed it to stay uniformly distributed throughout the bottle in order for the chemical reaction to work. I could shake it, but let's say that would ruin the chemical reaction as well. In order to keep that mixture and have that reaction that I know is possible, I need to turn off gravity in this case. And so this happens in pharmaceuticals quite a bit. So that's just one example of how we can uniquely manipulate chemistry in a zero gravity environment. And our customers, quite frankly, don't even care that we're going to space at all. If we could invent an anti-gravity box in the back of our lab, they would much prefer that because everything would be way cheaper. But thank God, according to Einstein and the equivalence principle, if you want zero gravity in perpetuity, you got to go to space, dude. All right, so what are we going to manufacture in space? Well, microgravity is a very generic technology, obviously, since all of engineering is built on it. And so I think of the entire global supply chain, and now I apply some filters. The first filter is, can we add value to your manufacturing process if we manufacture it in space? If so, can we design a robotic satellite to do so? And if so, can we capture enough value and integrate into the supply chain? And so there are 3 to 4 products or sets of products that fall through these filters and now make it through that last one. Can we capture enough value? And it makes it through now because of the lower launch costs due to reusable rockets. So the R&D department of Varda is essentially the last 2 decades of science that's been done on the International Space Station. We take that science and we just say, which one are we going to make the highest margins off of, and we go down the list. The International Space Station is a great research platform, but it's not a mass manufacturing facility. One other thing I'll note is what this actually looks like in practice. So what we do is we put up robotic satellites with the manufacturing apparatus that manufacture these products, and we make capsules that go up into space, rendezvous with the manufacturing satellite, brings the raw materials with it. Once it gets to the manufacturing satellite, it exchanges those materials for finished product, and then comes back with the finished product. So essentially just an in-orbit manufacturing assembly line. Okay, so here comes the cool part. And if I do my job correctly, these next 2 slides is where it will click as to how close this is to a reality to today and how impactful it is for the aerospace community at large. Okay, so first, reusability has lowered the cost of launch, which now allows the first few sets of products to be economical to make in space. So that sets off a huge positive feedback flywheel. We can now make a few sets of products, which at scale then causes launch costs to drop because we're demanding more launch, which as launch costs drop a little bit more, that now we have 4, 5 sets of products that are economical. That demands more launch, which then further reduces launch cost, which gives us 6 products, which further reduces launch costs. And it sets a positive flywheel until launch costs go to the floor and the number of products we can make go to the sky. So positive feedback loop in business, that's where you want to be, baby. Okay, so there is no saturation point in sight. And so so now that you see this flywheel is about to kick off, our business model is extremely simple. The more we launch, the more money we make. And it sounds so simple, but this is actually not true for any other satellite company in the world. Every other satellite company, there's only 2 ways to make money in space right now. Telecom and Earth observation. So telecom, bouncing signals, DirecTV, Sirius satellite radio, and Earth observation, taking pictures. Both of those businesses treat satellites as a capital asset. You pay for them once your constellation is populated, reoccurring revenue. So there's a saturation point. We treat satellites as an operational expense, and that fundamental difference means that we are the only satellite company that says the more we launch, the more we make. Everyone else says, well, once we get the satellites populated, we'll stop. But the more we launch, the more we make, and the reason for that is because our products are consumable, and we have to launch in order to bring them back. So it all kind of makes sense. Lemonade stand type business model. So who's trying to build this? Basically, engineers who get this, that concept, that click of the positive flyback wheel and the lack of a saturation point in our business model that will demand launch in perpetuity. Engineers always want to build what the next cool thing is, and the smart ones are thinking one step ahead, and they know that with reusable rockets, I worked at SpaceX for 7 years and had a blast there. Reusable rockets, we always thought of it as an end goal. It's a very awesome thing that happened, but at the end of the day, it's a means, not an end. It's a means for, what can you actually do with reusable rockets? Simply going back and forth in reusability, that's awesome for me, but it's not necessarily the best business. You actually have to do something with those reusable rockets. So engineers that get that want to build this. Engineers who want to bring space closer to Earth, and who wouldn't want to build the first industrial park in space. So here's our team photo. This was 6 months ago, so we're about double the size now. Dan and Mook are here, so I should have cropped your faces in too. Okay, so Drew is gone, so let's talk a lot of crap on Drew while he's gone. No, I'm just kidding. El Segundo is a great place. I used to live in New York when this idea was presented to me, and the reason we set up shop in El Segundo is because I wrote a script, a software program, to scrape LinkedIn and other job recruiting sites to figure out where the engineers were that I wanted to hire. And El Segundo was the clear winner as far as technical chops. Satellites, aerospace. San Jose, actually number 2. So it was a little bit of a trade, but I love El Segundo, so here we're here. And at the end of the day, it's the engineer that matters, because the source of all value of every tech company is the brain power of the engineer. And I believe it was Will Bruey at the South Bay 22nd Annual General Assembly that said that. Okay, so our strategy is pretty simple, and I'll go through these slides a little bit quicker because this is more of the boilerplate stuff, and then we'll get to the dope video. So first, the way to win in aerospace is get your hardware off the ground. The faster and the more working hardware off the ground, the more successful you're going to be. Everyone in our company is a systems engineer, so that means that people who design it also put it together for the first time. And in order to be an effective engineer, you got to have that line of sight all the way to success. So folks who consider themselves design engineers but don't want to turn a wrench need not apply. We develop products in-house first, and then turn into a platform. So the analogy here is the Apple App Store. First, Apple designed the App Store, but they also did the first few apps to show everyone how it worked. So we create the first few products manufactured in space, and then we open it up as a platform for anyone who wants to manufacture and take advantage of zero gravity. And of course, we're taking advantage of a new layer of commoditization in the aerospace industry, thanks to a flourishing aerospace industry. When I started at SpaceX, everything was much more craftsman. Now it's more like Walmart trying to buy hardware for space. And over the course of human history, we've kind of seen some repeats, how industries are developed in different ages. Usually militaries first. The first tools that were found were spears. Then telecom, then manufacturing, and then tourism, right? The oil industry came before Hilton hotels. So our bet, the bet that Varda is making, is that the next big commercializable industry in space is manufacturing, actually before tourism, because one, it's easier to engineer, and two, there's more money there. Okay, so what does it all mean? How does this actually impact everyone here? Space will feel a lot closer to home, and I think the best analogy is it will feel like the ocean. Right now, nobody here probably has been to a oil rig, even though you see them off the coast of Long Beach, but they're part of the day-to-day supply chain. And as you saw on the first slide with the map, they're about as far away as space. So space will feel closer in kind of the same way that oil rigs, you don't see them every day, but they're nearby. They're in the economy. So that's what space is going to start to feel like. We'll have an entirely new capability for chemists. So I think of it as like MRIs. When they first came out, it's an entirely new capability for doctors. Space work, space tourism, asteroid mining, all these things won't sound crazy in about 10 years. And of course, hopefully we have some revolutionary products that create some trickle revolutions of their own. and you'll see more contrails in the sky from all the capsules coming down with the products. All right, so that's the deal. Here's a picture of what the in-orbit manufacturing satellite will look like, and one of our capsules that go up with raw materials, dock, exchange the raw materials for finished product, and come on back down. All right, any questions? Yeah, sure, shoot.
Gary from Redondo. How and who, somebody, before you launch a satellite, you have to know where the other 15 or 20,000 other satellites are. Somebody has to keep track of those. And it's not like the freeway. They're up there. So who and how do you do that?
This is a great question. So, yeah. How do we track all the things in space? There's quite a few organizations that do this. We have one thing on our side, which is space itself is enormous. So if you just imagine the Earth and everything that's on it, and now you make it bigger as to where space and orbits are, you would have to, it's space is much bigger than Earth, so you just get lucky 99.99999% of the time that you just can fly blind and not hit something. But there are organizations, so for example, we have to do an ODAR, which is a debris assessment, to make sure that where our spacecraft goes is not where something else goes. So there's both government bodies that do that, and actually Dan, who's here, is in charge of all of our regulatory efforts. And part of that regulatory effort is to declare that ODAR where our debris could be. And the FCC, NOAA, the FAA are all involved in that. And there's also private organizations who track in-space debris as a service. But there is a lot of stuff up there, but there is a lot of space too. So,
yes, thank you. What are the carbon impacts to Earth, to us down here, and as well as how do you protect or guard that investment against piracy in space, Russia, North Korea, and others? So I think we need to consider those elements.
Yeah, sure. So as first, the first part of the question. I'll go to the second part first. How do we defend against state actors and other maybe malicious threats in space? The short answer is the same way any other commercial business does. At the end of the day, it's just us up there as humans, and there's laws and regulations to account for them. Quite frankly, there's not as many in space as there is in Earth or on Earth, and that is always a risk. But in the same way as if there was an act like that against an American business on Earth, there is a retaliatory threat in space as well. And the second question was talking about carbon, or second part was carbon emissions. It's a great question. So every Falcon 9 rocket has about 3 times the fuel, burns about 3 times the fuel as a cross-country 737 jet. So we can put just over more than a dozen of our capsules on that spacecraft. So to a rough order of magnitude, we're a little bit less than a 737 flight. So I figure if FedEx can make a business transporting their products, then we should be able to make one as well. But I totally agree, if I wasn't doing space tech, I would definitely be doing green tech. I think it's the biggest existential threat in the near term. So it's not something that we take lightly by any means. But it's not quite that bad in terms of carbon emissions for this particular business. And one thing I'll also add there is because our constellations are low, we actually have to actively keep them up. And so if a satellite were all of a sudden to go unresponsive, it will drift back into the atmosphere relatively quickly. So we don't have any issues with chain reactions of collisions known as Kessler syndrome in the industry.
Thanks, Will. That sounds so exciting. I'm Christine Ng from Redondo Beach, and I'm so excited to see this. One of the questions I have is that it looks like you're going to have a factory in outer space. So what about the factory workers? Are they on Earth, or are they in space? And how many of them are you going to have? Thank you. And I want your business card, too.
Yeah. Thank you. So at first we'll have none. It'll be purely robotics. So there's actually, believe it or not, there are competitors in the manufacturing and space industry. So one of our friendly competitors called Axiom, they're taking a different approach. They're going humans first, and then once the factory is built, then they put the products inside. Our approach is kind of the other direction, and so we focus on what products we want to make first, and then we create the automated systems to do that. And that's roughly because I'm an engineer at heart, and it's easier to engineer for things that don't involve humans by a lot. Now, I always kid around whenever we have a call with the Axiom guys is we're building the products towards the factory, and they're building the factory towards the product. So I always kid around. We'll meet you in the middle. So at first, no people. But decades from now, they would we'll grow. And in fact, to have people in space, and I always kid. I give some metrics of success to the team, and one of them is. We'll know we're successful when we put a human into space and they come back with more money than they went up with, working class citizen. Because right now, everyone who goes up is essentially just a very expensive meat sack. So we want to change that. Cool. All right. Well, thank you very much, guys.